Thank you, Tib, for organizing this. I'm José Joaquín Atria, and I'm going to be talking about automatic observability. A little bit about me. I work for CV Library, and yes, of course, we're hiring. We have remote roles, and we're hiring people who work in Perl and Go and PHP. And it's in general a nice place to work. The stuff that I'm going to be talking about today is actually stuff that I did for work. I wouldn't have done otherwise. And the reason I'm here is because I'm coming to conferences and participating in the larger community is part of what we do. So anyway, with that out of the way, the slides for this presentation are on the URL on the screen, which I'll post on the chat, just in case. And I'm going to be talking about a module which is not on CBAN, not yet at least, but the code is available on the GitHub repository, which is on screen, CV-library, newfangle-agent. The general outline is going to be separated into 3, maybe 4 parts. First, very briefly what I mean by observability. Then a little bit about what about it is automatic. Then how all of that works, and then if there's time, I did prepare a live demo, but I'm not sure if we're gonna be able to make it. But you know, there's always hope. So part 1, exactly what do I mean by observability? Well, observability is very broad. It's a broad area, and specifically, I'm going to be talking about like application performance management, APMs. Broadly speaking, I mean, it's the sort of thing that you think of when you think of observability. You identify key performance metrics for your application, and then you have some way to measure them and keep track of them, and you use that information to identify bottlenecks and increase the performance of your application, or at least monitor it. There is a number of solutions that are already in place for this. There's things like open tracing and open telemetry, which are industry standards that are in development. I think open telemetry is probably going to be the one that is going to be the most widely used, but it's still being developed. So whether you're able to use it or not currently is a little of an open question. There's things like Prometheus, and there's other applications which also broadly fall within this category, like Grafana, or even things like StatsD, which I guess would also fall within the umbrella. Specifically, the platform that I'm going to be talking about a little bit, or that I'm going to be using, is New Relic. New Relic is it's a cloud-based monitoring platform. It provides a large number of features. It allows you to aggregate logs and stack traces and event data, and it provides this, nice data browser that you can use to explore the data, but also to generate dashboards and reports that you can use. I mean, that description applies to several other similar products. One thing that makes it useful or special is what makes it automatic. So this is probably also offered by other providers. Of that, I'm not entirely aware. But I know that at least New Relic provides these what are called language agents. These are language-specific solutions, which ideally you install or you execute in some way, and they bind into the language or the environment that you're running your application on, and this is the important part. Without any code changes, it keeps track of all of the code that is running, how long it took, what code it executed, how long that took, and it enables you in effect to basically run a profiler in production, which probably sounds like it would be a terrible idea. Speed is one concern. I guess security is another concern. But these are all concerns that you have to evaluate when you're using it. In terms of speed, well, how slow is too slow? In our case, we're running it on a platform which is a several million line long 20-year-old application. So there's definitely some bottlenecks there that we want very much to find and get rid of. So for us, at least, this application was interesting. As this might not come out as a complete surprise, but when I said that the language agents were language specific, it means that there's different support for different languages. Languages like Python, PHP, Node, Ruby, those are fully supported. You install the agent and you immediately get all of the coverage. There's partial support for languages like Go or C, where basically what you have is an SDK that you can use to add the monitoring yourself. But of course, that gets rid of the fully automatic part. There's still some manual work that needs to be done in the code base to get the best coverage. And there's no official support for Perl, which is a pity. So because the company that I work for was very interested in this, they came to us and said, well, there's no official support, but we need to build it. And my response to that was, it cannot be done. And then when they insisted and I thought about it a little bit, I said, well, I guess it can be done, but I cannot do it. And then when they kept insisting and I thought about it a little bit, I said, well, maybe I can do it, but it will definitely be too slow. And in response to that, they said, well, how slow? Because, how slow is too slow? And I started thinking, and I didn't actually have an immediate answer, and I was starting to run out of excuses. So I decided to create a first version out of spite. My goal here was to spend a couple of hours working on this, seeing how far how long it took for me to get completely blocked, and then get back to the business and say, I can't do it, it's too slow, forget about it. So how did this start? The support that exists for using New Relic on CBAN currently is a library called Newfangle that actually makes use of FFI Platypus to talk to the C SDK. So remember, I said that there was a partial support for C that uses the same solution basically. So with Newfangle, you can bind into the C SDK and use it just like you were using it in C. The API works with a fire and forget model. So it basically just sends the data over to a daemon that runs locally. And then the daemon off-band takes care to send the data to the remote host whenever it can or wherever it feels like it's a good time. That means that transfer rates, the transfer cost in your application is very, very, very little, or ideally very little. And the way you use it normally, if you're doing this manually, is a little bit like this. So at some point in your code, you create an application with the Newfangle, so a Newfangle app, which includes all of the configuration stuff. And basically takes care of talking to the daemon. And when a transaction comes in, you start the transaction. When a request comes in, you start a transaction. This is probably done in some middleware. And then when you're doing work, you take that transaction and you start a monitoring segment, which can have some metadata attached to it. And then at the end, you at some point say, the segment has ended. We need to stop keeping track of this. And that's fair and good. of course, like I said before, that model, that API is not particularly unique to New Relic, but we could change this to use any other solution, but we are talking about New Relic, so some of the examples might get a little specific, but bear in mind that the backend can change. Good, so we can capture these monitoring segments, but we want to do this programmatically because the idea is to see how slow it would be to capture everything. And on cPann, there is a solution for this. We can use hook lex wrap, which works a little bit like this. So you use it and it exports a wrap function, which takes a function name, and then it takes two handlers, a pre-handler and a post-handler, and those are just sub-reference. So we can store a reference to the segment when we call the function, and then when the function returns, we undefine it. We make sure that the destructor runs, and then the segment ends. And once we have that, we can put that into a little function. Wrap sub takes the package name and a sub name, and just does all the things that we just did. We actually couldn't use hook lex wrap directly because of a problem with catching exceptions, but for our solution, we're using a local fork. Might end up using making that contribution upstream, but for now it works for us. So we can wrap a function by name, but this is where things start to get a little tricky because we need to wrap all of them. So what you can do is you put all of that into, we go one level up to wrapping all of the function in a package. So we put it in a wrap package function. And then we take a package name and we use namespace clean to get all the functions in the package. And then we can run through each of these functions and we can filter the ones that we're interested in, get rid of the imported ones and the ones with prototypes, which are tricky, and private methods and anything you want. And then you get the subset of functions that you're interested in and you can wrap those. And once you can wrap a package, well, you can put that in a function that takes a file name or a module name, just like you would pass to, for example, require. And you can run that in an import, on import for all of the keys in Inc. And presto. You basically make sure that whenever this file gets loaded, we look at everything that has been loaded at that point, everything that is in Inc, and we look at all the modules and then find all the package in there and all of the functions and wrap them, and we execute code before and after every function in every package. And this worked. We put it in our code base and we immediately started getting data, and the data was very useful. So it wasn't actually that slow. This worked in part because our main use case was a Dancer web app, which has a single entry point, and we preload all of the code before forking. So we had a point at which we could run this code and say, this is the code we are interested in, all of the code that has been loaded up to now. And this was good enough. But it wasn't really good enough. And that leads to this current version of the code. This was motivated in part because we have more code than just the Dancer app. We have cron tasks, we have scripts that are run, we have long-running tasks, and we have other microservices that are written in Perl. Ideally, we also want to put this solution on cPann. And of course, at that point, you need to worry about the code that gets run at any point, ideally. So we need to catch runtime requires. And this is when things started getting very interesting. There are some solutions to this. You can put a code ref in Inc. You can use some modules in cPann, require hook and require hook chain. But these all allow you to run code before or instead of require, which is not what we're after. What we want is to be able to load the, call require. That require will load the code, and after the code has been loaded, we want to run the same process that we ran before, where we identify the functions in those packages and wrap them. Somebody was asking if you could use something like devel trace. I think that falls within the category of I cannot do it. It can be done, but I cannot do it. There's definitely ways that are smarter, maybe, or more efficient to do all of these things, but these are basically the things that I managed to do by myself to answer this very specific questions. Is this even possible for us? But yeah, there's probably better ways to do this. So anyway, back to patching require. I couldn't actually find anything on cpan that gave you the API to do this, but I did find the module called lexical seal require hints, which doesn't actually do this. It doesn't actually help us to do this, but it shows how you can do it, because it needs to do it itself to fix a problem with a hinting bug that affects some versions of Perl. And I'm not going to go into too much detail about how it does it, because I understand about half of it. But the core of that looks a little bit like this. And I'm very glad that Sefram had to manage to do this, because it means that I can just copy the solution. And even this is not complete. This is about half of it, because the real dark magic is here, where we're basically, requirer is a reference to something that basically is the real require. And that involves, stringy eval into the calling package. It's not pretty, but it does work. After we call this, we can actually wrap the module with the same argument that was passed to require, and wrap module will do the right thing with it. There are some limitations to this approach, but we don't really care about Perls that are older than 5.12. So that works for us. So all of this code is in a distribution that is a little experimental. It's called Newfangle Agent, since it's built on top of Newfangle. All of the decisions that it does about, for example, which functions are relevant and which libraries are relevant is controlled with config files. And it tries to do all of its work on compilation time. So it wraps all of the relevant code on import, all of the code that it finds that is relevant after it, at the point it was imported, and then it patches require so that anything that is loaded afterwards is also wrapped. And like I said, it tries to do everything that it can on compilation. It tries to do everything only once, which means that most of the cost of using this is paid on startup. In our case, this has led to startup costs about 10%. So there's about a 10% increase in startup times, which for us is fine, since we only pay that basically on deployments. And I can show you a little bit. I have like maybe a minute and a half. So these are some requests that I recorded yesterday that I wanted to show. So this is this demo application that I wrote. And you can see this is the New Relic interface. You have the transactions here. And these are the transaction traces that I've been capturing from these transactions. So for example, if I click on one, I can see a summary of the request, method, status, stuff like that. But also, very importantly, I have the trace details. So I know which controller was called and which classes it called and which functions. And this is, I'm hearing that there might be some problem with the sound. I hope there isn't. And again, this is without me doing any code changes other than enabling this feature. Here, I'm only tracking the modules of this particular application. but actually you can, if you don't use that filtering, you will get basically a trace of everything. So you see, I'm getting a lot of the uh, information about how module issues handle this. And then all the way on the bottom, I get the controller and the model of the application itself. So it really is capturing basically everything that executed. And it's also capturing stuff like database queries, including the query itself that executed and how long it took. And that's about it for my presentation. Feel free to try the demo yourself. Accounts, you would need an account on New Relic, but New Relic accounts for individuals are free. And if you are interested in running this on your stack, then let us know, because we would be very interested to hear what happens. There is the only other thing that I would like to mention is that we approached New Relic with this solution. We showed it to them, and they were interested, but they also said that the CSDK that this is using is probably on its way out. And what they're really interested in is to move towards open telemetry. So it's possible that before this hits cPan proper, this will move to a different backend, probably using open telemetry. And at that point, it's no longer tied to New Relic. It would be something that you could use with basically any of these providers, since the core mechanic, that wrapping everything and detecting all of the code that is relevant, that is already in place. What backend it talks to is just a detail. And that's my presentation. If you have any questions, I'd love to answer them.